You may have heard the term object-oriented programming. This is where you can create objects in your program that are isolated from the rest of the program. They can have their own properties and methods. The data and the instructions that manipulate the data are all in a single location. This is known as encapsulation, and it keeps one part of the program from messing with data that another part of the program uses. So why is this important? The separate object with its related properties and methods can work properly and be isolated from the whole program, minimizing crashing or unexpected results. Once the object's created, we can use the properties and methods associated with it and not have to understand all the intricacies of it. Like a machine that we just have to know how to turn on. We don't have to understand it all once it's created. Sometimes we create the object and sometimes the objects are already created for us. For example, strings and arrays are objects, and we can use the .length or the .count properties on them. We can also create objects representing models of the real world and create our own properties and methods. And once they're created, we can use them with this encapsulation that isolates them from everything else. Only certain programming languages offer true features of an object-oriented language. C++ and Swift are true OOPs, or object-oriented programming languages, and it can be argued that JavaScript is object-oriented as well, but it does lack some features that true OOP languages have. Objects will isolate two items from the rest of the program: the data, or the properties and their values, and the instructions or methods for manipulating that data. They could be pre-made objects like the document or terminal or console that we've referenced before with things like print or document.write. It could be an array or string that we've accessed to get a property from, like the .length or the .count properties. It could even be an object like date that grabs the current date for you from the computer. Or we can make our own objects to represent something in the real world that we need to work with in our program. Here is a representation of an object, a car, with properties and values for those properties. For this particular object, it has a make, a model, a weight, a color, and a current speed. We could represent the properties with name-value pairs like the following. Car.make would be assigned Fiat. Car.model could be assigned 500. Car.weight could be assigned 850 kilograms. Car.color could be assigned blue. And car.current speed could be assigned 20 miles per hour. Objects can have methods as well. For example, a car might be able to start or drive, brake or stop, and change speeds. These methods or instructions might be represented with the following: car.start, and then we see some empty parens following each one of these that are typical of a method. We also have car.drive with empty parens, car.brake with empty parens, car.stop with empty parens, and car.change speed with empty parens. If you had an object that represented your employees, you could have their attributes that describe them, or their properties like name, address, pay rate, department, etc. You might also have a method that would take their pay rate, property and use the weekly hours property and their pay rate to calculate the pay for the week. This would be a method for manipulating the data that belongs to the object. So we have the properties employee.name, employee.address, employee.payrate, employee.department, employee.officenum, and employee.weeklyhours. And we can have a method that uses the properties and creates additional information for us from those properties. For example, the employee.weeklypay is the method. You could create an object of just one employee. Perhaps you have a program where just one object is needed. For one employee, the code looks like this as seen in JavaScript. We have var Tom employee, and being assigned to that, it is all the things inside the curly braces. We have name, Tom, address, 123 Street, pay rate, 35, department, accounting, office num, 301, weekly hours, 40, weekly pay is a method represented by an anonymous function that returns the pay rate times the weekly hours of the Tom employee. The object is named Tom employee, and inside the curly braces are all the name value pairs that make up the data that goes with the object Tom employee. Later in code, to refer to that object's address property or the object's method of weekly pay, you would use the following code. Now when we look at this, notice the period or dot that follows the object and begins the property or method name. This is referred to as object dot notation. So we have the name of the object followed by dot and the property or the method. Methods usually have parentheses following them because they could possibly have parameters that are used with them. So we have to refer to the object now, Tom employee dot address. This would then result in 123 Street because that is Tom's address. Again, the second line we have Tom employee dot weekly pay empty parens. This would result in 1400 because it's taking Tom's pay rate 35 and timesing it by his weekly hours, which is 40. And that's a method that we created that we can now just use with the dot notation. But many times you'll want a lot of objects with the same type of properties, like all of the employees that work for the company in your program. In that case, you need to have a way to build them all easily in one group. For this, we will use what's called a class. The first step to creating a group of objects is to define a class. A class defines the data that you will store in the objects. In our example of employees, the name, address, department, pay rate, etc. as properties along with any instructions that manipulate that data. In our example, the weekly pay calculations, that would be a method. These are general data fields and a method and not specific employee data yet. Just how we want to organize our object and outlining what information we will have in the object. So a class is like a blueprint. From that blueprint or class, we can later build the actual objects. So once we have an employee class set up, we can create many actual objects representing actual people from that class. Each can be a bit different because the values that go into the properties will be different, but they all have the same structure. Just like a house blueprint can be used to build separate buildings, but they can have different characteristics. Here's a blueprint for, or class definition of creating a car object using JavaScript type syntax. It has 3 properties or categories to store property values later. That each car object can have a year, make, and a model. It can also have one method or instructions to manipulate the data called getInfo that will simply return a string with the make, model, and year inserted into it. We have function, the name of the object with a capital V, vehicle. Inside parens, we have 3 parameters, the year, comma, the make, comma, the model. Inside curly braces is how we are setting up our object. We have this dot year equals the year. So using the parameter coming in, we're going to assign that to this particular object's year. This dot make is going to be assigned the make that came in. This dot model is assigned the model. And this dot info is assigned a anonymous function that represents the method that will return the string vehicle concatenated with this current object's year, make, and model. Here is the same similar thing in Swift syntax. Here they use the keyword class, and again, a capital vehicle, inside curly braces, var year, colon, integer equals 0, var make, colon, string equals empty string for now, var model, colon, string equals empty string for now, function for the method getInfo, empty parens, curly braces, surround print, vehicle, year, make, model, and 2 ending curly braces to finish it off. Okay, going back to the JavaScript, here we see 2 objects getting created with that original car blueprint in JavaScript. The vehicle object is called, and the property values are placed in it to create a car. This will happen for the Ford and the BMW. We set up a variable car1, and it will be assigned a new vehicle object, sending in the 3 parameters, 2000, the string Ford, and the string Fusion. We're setting up a second object using the new vehicle object, and we'll send in 2010, the string BMW, and the string Z4. At this point, we're using the blueprint or the class that we set up to create the 2 actual objects from the class or vehicle. So what do you think would be stored in result with the following code? We have var result, and into it is going to be assigned car1 dot getInfo. So if you look back at the class that we had before, we will be assigning vehicle colon 2000 Ford Fusion as a string to the variable result. Because back at the class definition, the getInfo method returned the string vehicle with the current object's year, make, and model. Here is 2 instances of or objects made from the class car, this time in Swift syntax. Here we use the keyword let for a constant called car1, and it's going to be assigned the vehicle object. And it will be assigned the car1.year will be assigned 2000, car1.make will be assigned the string Ford, car1.model will be assigned the string Fusion. Car2 will be also using the vehicle class. Car2's year will be assigned 2010, Car2's make, BMW, and Car2's model, Z4. The C++ code here creates a monster class. It reads class monster, open curly brace, public colon, int x underscore coordinate, semicolon, int y underscore coordinate, semicolon, void movement inside parens int, comma int, semicolon, void initialize inside parentheses int, comma int, semicolon, ending curly brace, semicolon. Here a new class is created called monster. The class definitions are inside the curly braces. The public command says that the property and methods can be accessed by any part of the program. Two properties are created with the variables x underscore coordinate and y underscore coordinate. There are two methods, one to move the monster called movement, and it accepts two parameters that are integer values when it's used. The other method, called initialize, also accepts two integers. This class is not an object yet. It's just a blueprint to make different kinds of monsters from, or in this case, to probably have monsters in different XY coordinates on our monitor. Since this is an example of a class, it's not an actual object yet. We need to define the variables that would represent our defined class. So, following the class we originally set up of monster, you might build an object from the class, and it might look something like this. Int main, empty parens, opening curly brace, monster zombie, semicolon. Zombie.initialize, and it's sending in the parameters 12, 15 as integers. Monster.moveMe, the other one was movement, they should have both been moveMe, and 34, 9 as the parameters going in. Semicolon, ending curly brace. When main runs, a new monster, a zombie, is created using our blueprint of monster. This new zombie object can now use the methods in the class that initialize its location and give a value to the x coordinate and the y coordinate and move it around. Here is a JavaScript example for employee, a blueprint for creating employee objects. Function, capital employee, because it's an object, we capitalize it, first name, comma, last name, age, comma, department, comma, pay rate, comma, hours, comma, all in parens, opening curly brace. This dot fname is assigned the first name that came in from the parameter. This dot lname is assigned last name. This dot bdate is assigned age. This dot department is assigned department. This dot pay rate is assigned pay rate. This dot week hours is assigned hours. This dot weekly pay is a method using a function where it returns the current pay rate times the weekly hours. You can then create instances or objects from this class, actual employee objects from that employee blueprint. Here we're creating two. var employee 24 is created. It is using the new keyword and the object name that we set up called employee, and we're sending into it the first name, last name, age, department, and the pay rate and the hours. So Jane Jones, 23, accounting, 14 is her pay rate, and she worked 40 hours. Another employee, employee 25, is also using the same blueprint. This is Sam Smith, who's 31, from Human Resources, and he is paid $20 an hour and works 40 hours a week. So now that we've created those objects, we can refer to them in the code. So two employee objects are being created using the employee class. The data is fed into the employee function, and now we can use the properties and methods for those employees. In code, we would refer to a property of one of our objects using dot notation. So employee 25 dot department would give us a human resources, because that is Sam Smith's department. Employee 24 dot weekly pay, empty parens, would give us, would call the method weekly pay for employee 24, meaning it would give Jane Jones's weekly pay in hours, times them together, and that would be $560 that she earned that week. Okay, inheritance is another concept you see when talking about objects. Inheritance would allow you to reuse one object's properties and methods with another type of object. I'm not going to go deeply into these more advanced topics much, but say I wanted to now make a subclass of employees which could use similar properties like name, age, and department, but use it for our clients instead of our employees. So, our subclass would inherit properties from the original class employees and override properties it wouldn't need, like pay rate, and could also extend it with new properties that we might need for the client that the employee didn't have. This allows you to reuse the parts of the code instead of having to recreate them from scratch.